Welcome to EPG Pathsala Architecture lecture series for MArch students. In this lecture, we are going to see about the wind energy system and particularly the components, wind energy system components and the terms and definitions and advantages and disadvantages of wind turbine generators. And this is about horizontal axis wind turbine. The horizontal axis wind turbine is quite mature technology, and worldwide it is accepted, and for electricity generation everywhere horizontal axis wind turbines are being installed. And about 20 years back, the machines were designed with a low capacity starting from 150 kilowatt. Then the technology improved to 200 kilowatt and then 500 kilowatt, 750 kilowatt, 1 megawatt, 1.65 megawatt, like that it kept on increasing. And there is machine for about 5 megawatt, single turbine generates 5 megawatt capacity. In Germany, there is one wind turbine which has capacity of about 7.5 megawatt capacity, and the technology is improving day by day, and this is about horizontal axis wind turbine, and and it has heavy components, and all this body it is standing upon the stem, the tower. The tower supports the entire structure of the wind turbine, and this is the rotor. In other word, people call that it is hub, and this is the front face of the hub or rotor, and it has 3 massive blades, and the 3 blades turbine it is highly optimized one. Everywhere horizontal axis wind turbine will have 3 blades, and this is complete part is called nacelle, and in that case, and here we have the transformer and then generator, the gearbox, and this is the hub, and this is the tower, and these are the major components of wind turbine system. These are all heavy components: gearbox, generator and transformer. These are all very heavy equipments, and which is supported by the tower. And these are the interior components of modern wind turbine, and this is again horizontal axis 3 blade wind turbine, and these are the blades, and this is the rotor, and from the rotor we have the low speed shaft. The speed may be on the order of 200 to 300 RPM, and it is not sufficient to generate electricity, and it has to be stepped up to 1500 RPM or 1800 RPM, and that is why there is the gearbox, and the low speed shaft is connected with the gearbox, and then the speed is stepped up, and this is the generator, and the generator will have high speed shaft here about 1500 RPM, and from the rotor shaft we get about 200-300 RPM, and it is stepped up through the gearbox, and it is about 1500 RPM. The generator generates the electricity which is given to the grid, and this is low speed shaft, and this is the high speed shaft, and it has various components like here we have the anemometer to measure the wind velocity, and this is about the wind van, and it helps to identify the direction. The wind van and it identifies the direction of the wind speed, and the anemometer will measure the velocity of the wind speed. And the wind van will give the direction to the yaw mechanism. Yaw mechanism is here, the yaw motor which takes power from the shaft, and the yaw drive mechanism is here, and after taking the signal from the wind vane, and it helps to twist the phase of the rotor according to the wind direction, and the wind direction keep changing in a day season wise, and the yaw mechanism is very important device, and it takes signal from the wind van, and it is operated from the power of the shaft, and then it tilts the phase of the rotor according to the wind direction. And so these are the blades, and this is the tower, and this is the yaw mechanism, and so these are the interior components of the wind turbine system. And so all the components have to be maintained properly. So in this, mainly the yaw control mechanism will get affected because it kept on working. Whenever the wind speed changes, the yaw control takes care, and the yaw motor, and it chances for failure, and gearbox sometimes it fails, and sensors, because these are all electronically operated, and sensors maybe fail sometime. That is why the maintenance is very, very important to nullify the downtime of the wind turbine. This is the cut section of a typical wind turbine, and this is the rotor, and also called hub, and these are the blades, and rotor brake and generator, yaw mechanism, and this is a tower. All the controls are there inside the tower, and this is the foundation, and this is a schematic diagram of the wind turbine system, so which identifies major components like the gearbox, the generator, yaw mechanism, the rotor, and the brake, and the hub, everything. And this is about the wind turbine generator, and here you find the generator rotates, and the high speed shaft is connected with the generator. It rotates in the order of 1500 to 1800 RPM. The wind power generators convert wind energy, that is mechanical energy, to electrical energy. The generator is attached at one end of the wind turbine, which provides the mechanical energy. At the other end, the generator is connected to the electrical grid. The one end is connected to the grid, other end is connected with the mechanical shaft. The generator needs to have a cooling system to make sure there is no overheating. This is about the generator. And other components of the gear transmission, and this is the low speed shaft from the rotor, and this is the low speed gear, and it is connected with the high speed shaft and high speed gear, and it rotates in the order of 200 to 300 RPM, and this rotates in the order of 1500 to 1800 RPM. It is connected, the low speed shaft is connected with the rotor, the high speed shaft is connected to the generator, and here we have high speed gear and low speed gear, and the connects the low speed shaft of the rotor to the high speed shaft of the generator. Speed of a typical rotor may be in the order of slightly higher, of course 200 to 300 RPM, and generator speed may be slightly higher, 1500 to 1800 RPM. And the components of a wind turbine in details: anemometer, it measures the wind speed and transmits the wind speed data to the controller. So, anemometer always it measures the wind speed and it gives the data to the controller, and so according to the wind speed and the machine starts and the machine stops, and when it reaches the cut-in speed it starts operating, and it gets down when the speed exceeds the limit. And the blades, the most turbines have either 2 or 3 blades, but then now we have only 3 blades turbine. Wind flowing over the blades, it causes the blade to lift and rotate. And nowadays only we have 3 blades, and it has composite material, and there is another important component, that is the brake, a disc brake, which can be applied mechanically, electrically or hydraulically to stop the rotor in emergencies. And here the disc brake, and it is necessary at the time of emergency, it has to be applied, and some machines have mechanically operated brakes or electrically operated brakes or hydraulically operated brakes. And this is the controller. The controller starts up the machine at wind speeds of about 13 to 25 kilometer per hour, that is 3.5 to 7 meter per second, and shuts off the machine at about 88 kilometer per hour, that is about 24 meter per second. The turbines do not operate at wind speeds above about 88 kilometer per hour, that is 88 kilometer per hour, because they might be damaged by the high winds. And yes, so and the controller, it's a very good important instrument, and it gives the signal to the machine, and at the time of the right speed it gets started, and if exceeds the limit and it gets stopped. And the gearbox, gears connect the low speed shaft to the high speed shaft and increase the rotational speeds from about 300 to 200 to 300 rotations per minute, that is in RPM, to about 1500 to 1800 RPM, and the rotational speed required by most generators to produce electricity. So, the gearbox, it is a very big component in the machine, and it steps up the required speed to the generator. And high speed shaft, it drives the generator. Low speed shaft, the rotor turns the low speed shaft in the order of 200 to 300 rotations per minute. Rotor, the blades and the hub together are called rotor. And nacelle is the case, and the nacelle sits at the top of the tower, contains the gearbox, low and high speed shaft and generator, controller and brake. Some nacelles are large enough for a helicopter to land on. Pitch, blades are turned or pitched out of the wind to control the rotor speed and keep the rotor from turning in winds that are too high or too low to produce electricity. And the towers are made from tubular steel or concrete or steel lattice, because wind speed increases with height. Taller towers enable turbines to capture more energy and generate more electricity. The tower, it helps the machine to lift up all the major components, and the tower supports the gearbox and the generator, mechanism, the rotor, blades, everything. So, it needs very, very strong foundation. And there are a lot of towers available. There is freestanding tower, lattice tower, gate tower and tilt up gate tower, and the tubular tower. So, these are the various towers being used. And the wind direction, this is an upwind turbine, so called because it operates facing into the wind. Other turbines are designed to run downwind, facing away from the wind. there are turbines, upwind turbines and downwind turbines, and the wind vane measures the wind direction and communicates with the yaw drive to orient the turbine properly with respect to the speed. The wind vane, it is an important component. It identifies the direction and it gives the signal to the yaw drive to orient the turbine properly with respect to the wind. Yaw drive and upwind turbines face into the wind. The yaw drive is used to keep the rotor facing into the wind as the wind direction changes. Downwind turbines do not require a yaw drive. The yaw drive, and it takes power from the shaft, and it helps to operate the yaw mechanism, and it is a main component to tilt the face of the rotor according to the wind direction. Yaw motor, and it powers the yaw drive. And so, we have seen the various components of the wind turbine generators. It has very big components, as well as it has lots of sensors and controls, and the wind turbines need the periodical maintenance, the preventive maintenance, so that we can minimize the downtime of the wind turbine generator. And here we look at the small problem to calculate the annual energy production. How much energy will be generated in a year by a 100 kilowatt rated power wind turbine? And it is an interesting question. So, this 100 kilowatt wind turbine, how much energy it could create, it could generate in 1 year. So, number of hours in a year, it is 8760 hours, and rated power of the wind turbine, it is 100 kilowatt machine, 8760, and 8,76,000 kilowatt hour. This much units could be generated in 1 year, but then the capacity factor is just 30%, and so that is the load factor or capacity factor, or sort of efficiency factor. It is just 30% after all other losses. So, annual energy production, and this could be generated, but then because of the capacity factor is 30%, when we multiply this with 30%, that is 0.3, we could generate 2,62,800 units of electricity out of 100 kilowatt machine. And here we find some of the turbine blade designs, and so this is called airfoil or aerofoil, and so the wind is flowing in this direction, and this angle is called angle of attack, and this is the leading edge, and this is the drag, and this is the lift force, this is the drag force, and this is the resultant. This is the trailing edge. This is the shape of the blade, and aerofoil design, and this is the angle of attack. The alpha is the angle of attack. The air is blowing and towards this, and the blade gets lifted up. Airfoil or aerofoil, a streamlined air surface designed for air to flow around it in order to produce low drag and high lift forces. So, the wind is flowing and towards the blade, and I mean in the angle of attack, and it gives low drag and high lift forces. The lift force should be always high, the drag force should be always less. Angle of attack, the angle between the relative air flow and the closed of the airfoil. So, this is the alpha, this is the angle of attack. Air flow over the blade develops lift force and causes the blade to rotate. And some of the terms and definitions, and this is the solidity and the ratio of blade area to the swept area covered by the rotational rotor, that S is n into small b divided by pi d. N is number of blades, b is the blade width, and d is the diameter of the circle described by the blade. So, that is the solidity, and N b divided by pi d, that is the ratio of blade area to the swept area, and that ratio will give the solidity of the wind turbine. Energy pattern factor, and the ratio of power from speed distribution to the power from average speed of the turbine, coverage speed of the turbine blades. EPF, power from speed distribution divided by power from average speed, that is EPF lies between 2 to 5, that is the energy pattern factor. The tip speed ratio, that lambda, the ratio of the blades outer tip speed, that is U suffix bt, that is to the upstream wind speed, the ratio of the blades outer tip speed to the upstream wind speed, that ratio will be the tip speed ratio. And so, various advantages of wind turbine, and it is a clean and renewable energy source, and the wind it is a clean energy source. It is also renewable as long as the earth is there and the wind flow will be there. It never be stopped, it never be emptied, and it is renewable in nature. It is clean resource. There is no fuel component. So, once built, there is no reliance on a finite fuel supply. It does not need any fuel. There is no fuel component, and power can be generated in remote areas, hilly area, including offshore, where there is no electricity. In the remote area, power could be generated through wind energy, and also offshore inside the sea, power can be generated. It can be used to generate power in a local area or even at the individual property level. So, these are the advantages of wind power, and it is also cost competitive with the cost of construction of a wind farm lower than the construction cost of the many types of conventional power plants, and it is very cost competitive nowadays, but initially about 20 years ago the cost was slightly higher, but nowadays it has become cheaper. It is on par with conventional power plants, and it is lesser when compared with some of the conventional power plants also, and it is highly cost competitive, and it is not like solar or not like other renewable energy sources, and it is a quite mature technology. The cost is well competitive with the conventional power plants like coal based or oil based or gas based or nuclear based, and it is almost equal with other power plants. Wind generated energy costs less than natural gas at today's high price. When compared with some of the fossil fuels like oil and gas, it is lesser than that. Once the wind towers are installed, the land area around them can be used for other purposes such as agricultural use, and even after installation of wind towers, wind turbines underneath, and we can do the cultivation, and it has some disadvantages like the wind to drive the turbines may be intermittent, and that it does not always blow when electricity is needed, and whenever the wind velocity is there, and the turbine could generate the electricity. If the wind velocity is less than the cut in speed, and it cannot generate electricity, and so that is intermittent in supply. It cannot give continuous power supply, and it makes more noise of course, and because of the gearbox, and impacts on birds. So, when the blade rotates, it may affect the birds, and it needs storage owing to irregularity. Wind farms requires flat and vacant land free from forest. So, I mean it needs flat land and vacant land, and these are some of the disadvantages of wind turbine generators. And in this module, and we have seen various components of wind energy systems. Mainly, we have seen about the rotor, which has 3 blades, the hub, and it is connected to the shaft is having very less speed, and then it is connected to the gearbox. The speed is increased to the generator speed. So, in between we have generator, and then we have the gearbox, and we have the wind van. It measures the direction of the wind speed, wind direction, and it gives communication to the gear mechanism, and it will tilt the face of the rotor according to the wind direction. And there is the brake shoe, and at the time of emergency the brake is applied hydraulically or electrically or mechanically. And it also has lot of controls and sensors, and it needs periodic maintenance to avoid the downtime of the wind turbine generators. And it is quite mature technology. As we have seen all over the world, it is installed. In India in particular, we keep 4th position in the world, and we have installed about 28,000 plus megawatt of electricity through the wind farms. Particularly in the state of Tamil Nadu, we have installed over 7,500 megawatt of electricity. And we have seen about the advantages and disadvantages. And the advantages are, it is clean energy, it is renewable in nature, it never be exhausted, unexhausted energy source, and of course, it is renewable and clean, and wherever there is no electricity grid line, and then we can have some decentralized power generation in hilly areas or islands or offshore applications. So, and everywhere we can have wind turbine installations, but then it needs the minimum speed, that is cut-in speed about 4 meter per second, and it could operate up to 17 meter per second, beyond which and the system gets stopped, otherwise it creates some dangerous experience. And yes, of course, it has some disadvantage, and intermittent in supply. We cannot have continuous power supply, and as long as the wind speed is all right, we can keep generating electricity. The wind speed is low, we cannot generate electricity. That is why it is giving only intermittent in supply. And it needs, of course, storage in remote areas, and the wind farm, it creates huge noise. It may be disturbance to the residents, and yes, it has some minor disadvantages, like it will affect the birds and maybe the visual sight, and these are all minor disadvantages. And of course, the lot of research work is going on, and as we discussed, the capacity was increased from 150 kilowatt, nowadays about 7.5 megawatt of installed capacity. That is huge growth in terms of capacity addition. And apart from it, and in materials, lot of research is going on to make it less and compact. And apart from it, intensive research is going on to bring down the cut-in speed. Now, minimum speed requirement is 4 meter per second. People do continuous research to make it 3.75 or 3.5, and if it is successful, we have more potentials in the world. Maybe most of the places we can put wind turbines, and so people do lot of research in the blades and other components, and to bring down the cut-in speed. And definitely among all renewables, wind energy is playing a vital role, and it is being installed all over the world. Over 300,000 capacity has been installed already, and it gives good form of electricity, and it could substitute in the place of fossil fuel based power generation, and it will be a very good substitute. And in future definitely there will be further phenomenal growth in terms of wind energy generation. Thank you for listening.